all yours.
Okay, so thank Professor He for introducing me. I'm Lun Wei Ku from Institute of Information Science, Academia Sinica. Today I'm going to talk about creating resonance, sentiment, and preference-guided text processing in social media. But I will not focus too much on social media because most of our experiments are performed on the social media data. Okay, before we start, please allow me to introduce a little bit about our institute, as I'm the only speaker from Academia Sinica today. And then I will talk about our motivation, why we want to create resonance, and then I will introduce some of our current research and conclude with our future direction. Okay, so Academia is the top governmental research department in Taiwan, established in 1928, so this year is celebrating its 90th anniversary, and it has a total of 31 institutes and centers. And I am in Institute of Information Science. We have 8 research groups, 39 principal investigators, including me, and 22 postdocs, and almost 300 full-time, part-time research assistants. These 8 research groups are informatics, computer system, data management and information discovery, multimedia technologies, network system and service, programming language and formal methods, and computation theory and algorithms. And I belong to the language and knowledge lab. But so I know that today we have many guests from Israel. So if you are going to find some collaborative partners for your research, here's the place you should look for. Okay, so, what happened? I'm going to the wrong direction. It sucks. A little bit, sorry. Yeah, I think so. Okay, so this is the outlook of our building and the photos of my colleagues. Okay, then I'm running the NLPSA lab. Our lab is mostly working on natural language processing, especially focusing on sentiment analysis and also the subjective information analysis. So we call the NLP as the lab of Academia Sinica. So in this era, we will think about if we are working on natural language processing, especially the subjective information, what can we do to contribute to the advance of artificial intelligence? We believe that the ultimate goal of artificial intelligence is to help people to achieve better life. I hope you think so too. So it's simple that our motivation is with artificial intelligence, we want to help people, but we want to help people in a comfortable way. We want to help people in their preferred way, and we want to help people in an enjoyable environment. If there is not such an enjoyable environment, we can create it. Or we want to care people. It's more like a psychological aspect. So, in fact, we expect more than just task accomplishment. Okay, so we believe that the developed techniques should be used in our people's daily life, and but you know, it's difficult if involving people. It's always difficult to evaluate. How can you say that an AI system is good? We must have. This is our belief, we must have achieved some progress when we say, oh, there seems to be a certain resonance between the system and me, So we aim to create usability, this is clear. And we want to create resonance. But what is resonance? Let's take a look at the definition in Oxford English Dictionary. It's about corresponding or sympathetic responses, such as in images, memories, and emotions, and overtones and allusions. This is the subjective information, exactly what we are working on. So in the past years, what have we been doing to create resonance? I will introduce some of my past research to you. related to creating resonance. I divide them into two parts. The first part is emotion analysis in dialogues. As we have seen that in dialogues, there are many, you can create good responses to create resonance. So I will introduce emotion detection and message suggestion. And the other part is user preference on web posts. And this part is we want to detect the user's preference so that we can predict their next behavior. That makes the user believe that we understand them. Okay, so it's a kind of a way to create resonance. Let's start from the emotion analysis in dialogues. Okay, so this is the very beginning of our research in this research trend. We developed the app called Emotion Push. This app will push emotions of the texting messages that you receive. So let me show you how it works with this video. Can I show a video here? Yeah. Okay, so when you start to use this app, it will hint you there are some colors which can tell you the emotion of the messages. So then, okay, so now you are talking to your friends in the Facebook Messenger. Then we will send you the text message as well as the emotion of this message. So you can see the color circles there. And if you see the color circles there in your notification bar, you can actually prioritize your messages. And then in the Facebook Messenger, when you talk to your friends, the emotion hint will be always there. So you can see the change of your friend's emotion. Okay, so this is our very first app for doing this. And this is an illustration of our dialogues. You can see that the left part is the dialogues when the emotion push is not enabled. And the right part is the dialogue when the emotion push is enabled. So you will receive a lot of emotional hints here, okay? And we did some experiments on this app. As you can see here, we have some graphs and spots. Each spot represents one participant. And we ask the participant to rate the performance of themselves and rate the performance of the other party in the same dialogue, in the same conversation. So here, the X bar is the difference between the score, the participant rate himself, and the score, the other party rates the participant. So you can see here, most of the dots are on the diagonal. Because we find that if your expectation, you think how good you are doing is different from the person you are talking to, then your conversation quality will be lower, okay? So this is when the emotion push is not enabled. But if we enable the emotion push and make the participants explicitly sensing the emotion they received, then you can see that the right lower part dots moving towards the left upper parts to make the conversation quality better, and also the rating of the participants for themselves and the other party for the participants are more consistent. Okay, then this is another app, then continuing the first app we developed. The first is about how you receive the emotion from the text message, but this is about how you can deliver the emotion in the text messages. So let me show you this app with this video. Okay, if you are typing some message to your friends, and you want to know what you should type, then with our app, when you want to type something, you just type the text in the text bar, and we detect your emotion, then we give you suggestion here, then you can directly use our suggestion. But if the suggestion is different from the mood you want to express, then you can swipe the suggestion bar, and you can select the message of different emotions, and you can send it to your friends. Okay, so here's an example here. If your friends send a message about how are you, they're asking how are you doing today, and the neutral one is you can reply I'm fine, but a little bit boring. So if you are sad, you could probably reply I'm upset, but I'm fine. Or you're tired, you can just reply I'm working. This is the suggestion from our system. So from this series of research, we have found 5 challenges. The first one is the continuum of emotion. We find that emotions tends to continue for the same person in one dialogue. It's not possible that the emotion change constantly for each utterance, right? So we will consider this in later model. And the multi-user conversations, sometimes the conversations include more than 2 participants, and it will make the emotion detection more challenging. And also, we found there are different dynamics between different users. If you talk to your friends you are very familiar with, then it's quite different to the situation that you talk to a stranger. Of course, there will be a problem of misclassification of emotions and unconventional contents, this kind of stuff, like emoticon or very long messages. Okay, so this is an example we have here. We've generated this data set for Friends TV shows. So you can see that this is a dialogue in Friends TV shows. And for each utterance, the emotions are different. So we proposed this model. This model is consider the challenges we discovered. So for we use the CNN model to model each utterance, but we use LSTM to model the context because you need to see the context to know the dynamics. And we also add this speaker switch mechanism in between the context so that even though we know the context is flowing, but we want to know when the speaker switches, okay? So with this model, we actually can improve the state of the art to 7% accuracy. Okay, so this is an example, just an example. You can see that with our model, you can actually identify an anger emotion when the speaker switches. Okay, so this is the data set we generate, including the Friends TV show and the emotion push, the private conversation that is very rare. So a total of almost 30,000 utterances are included in this data set. And also we launched Emotion X shared task in this year's ACL in the social NLP workshop, if you are interested. And the Friends TV show data set is public. But for emotion push, because it's private conversation, so you need to be participants to get this data. Okay, then next I'm going to introduce about the user preference on web posts. And the previous research is about the emotion and sentiment information that a user express or the user receive because it's in the text messages. But if we want to detect users' preference, they usually don't tell you using text or any speech like, oh, I do like this item, things like that. So you need to detect from their behavior. So in this part, I will introduce 2 of our research, including stance classification and article recommendation. Okay, so first, the stance classification is to predicting user or post stance. Like you are going to tell whether this post is supportive, neutral, or unsupportive. So in this research, we assume that, and we also find the statistics to support that. We find that people like to read posts of their own stance. They don't like to read posts that is having different opinions. And they mostly take the same stance with the posts they read. So this is the statistics we can show you that especially true for the supportive and unsupportive posts. Okay, so to deal with the stance classification in the very beginning, it's actually a cold start problem, because for many artificial intelligence research, in the very beginning, you don't have much data. So we propose a joint user post approach. That is, we utilize users' behavior to help us to modify the poster stance. Then we use the poster stance to help us to modify the user stance. So it's an iterative process. And later, when we get more data, so it's very common in our research life, right? Later, when we get more data, we can start to use deep neural network models. But in the beginning, we don't have that much data. We can't. So in the second stage, we propose the UTC model. It considers a user information, user behavior, and the topic information, and also the content information of the post to do the stance classification. Then in the end, we find that, okay, the user information and the poster information, they are structured and unstructured data. How can we combine them together and to optimize together? So we propose the model, Mr. Gi, which is a graph model, and we generate the node graph embedding for each node so that we can do the stance classification. Okay, so here is the model. Yep. In the very beginning, is simple Markov random field model, and you do the iterative things that to use the engagement between posts and users to do the stance classification. But later, when you have more data, what you can do is you can model the user's wording, different wording, and you can model the behavior or user scoring. And also, you can add the topic information here so that you can build this model. However, the unstructured data, like the post content, is here. The structured data is here. So actually, you are still using them in a different way. You cannot treat them as the same thing. And later, propose this Mr. Gi model is actually put all the words and posts and the users in one graph and using age to connect them. So we can generate the node embedding for each post and use it to do the post sense classification. So here we show you the performance. In the very beginning, we are working on the Facebook fans group. We got the average F1 score 0.67. Then to the deep learning model, we improve it like almost 8%. And then we start to apply it to the English open benchmark for stance classification. It's called Create Debate Forum. And then later, when we have this graph embedding model, we can improve the performance almost 10% on the public benchmark. Okay. So now we know that the user's behavior can be used to know whether they like this post or not. So it's their preference. Now we want to know, okay, if this works, can we use the user behavior to predict their interest on articles, to predict their reading preference? So here is an illustration here. You can see that when you go on the websites, we usually read articles like this. Here is the major articles we are reading. And then here are some popular articles you can click on. But when you scroll down, usually you can see some of the suggested articles. And you might want to clear them, or you might not. OK, so here we want to show you something we find in this research topic, that in the very beginning, we think the articles are products, because this is a very typical recommendation problem. And usually in the recommendation system, you have item-based, content-based, or some kind of combinations. But we found that articles are actually a little bit different from the products, because articles itself, themselves, their contents are actually products. We want users to read these contents. So we utilize some user features, but we find some conflict of interest here as for users, they want to view what they are really interested in, so it's views, like the articles you really read. But there are some records called clicks. These are what the content provider are interested in, because the clicks are linked to advertisement, and advertisement are directly linked to income, right? So I add a question mark here that are contents really products, because when we recommend products, usually we want the user to buy them. But here, you see, if we have more views, we may engage more users because users like what we recommend to them. But if we have more clicks, it can make more money. But these two are contradictory to each other. Somehow, there's a trade-off here. Anyway, we propose also a deep learning model to predict the views and clicks here. And OK, there are much detail here, but just show you some basic concepts that we use user-based model. We model the thread of views and a thread of clicks. If you have clicks, you not necessary to have a view. And sometimes the orders, people talk about the orders. They argue that whether the order in a local area matters. But in our experiments, we found the local order does matter. And here's some statistics that I just want to show you the scale of this experiment. In the largest website, we have millions of users' data, so it's actually very reliable model. And this is real data from our collaborative companies. OK, so we actually transform this recommendation problem, or you can say reduce to a similarity matching problem or a re-ranking problem, because for most commercial systems, they still use IR-based architecture. We consider the order of articles. It makes our model better. And in our experiment, we achieve average 5% to 90% improvement on the mean reproducible rank scores compared to the state-of-the-art item-based model. And we even did an A/B test in a real system, and we can achieve 90% performance compared to a manual keyword updating system. OK, so we now have trying to create resonance, either from what user express, from what user tell us, and from what user didn't tell us. So we believe that by modeling this subjective information and also the preference, we can make the further system more available or more easy to use for users. And I'll conclude my talk with some of our future directions. And the first one, better understanding of text is, of course, because we are natural language processing lab. And we want to help people express their feelings. Actually, we have done some experiments on foreign language learners. Like they usually don't know how to express feelings using second languages. And our next goal is to create resonance using both text and images. You can see that if we model emotions from both text and images, of course, it's multi-model models. So it should be better. And if we model image, we can talk to people according to what they see, like their photos or the scene in their space. And we can know users' preference better for sure, because as I show to you in this menu, usually people just select one eye-catching photo and click in. They don't really read the title, okay? Okay, so this is my talk today, and thank you for coming. Any questions? If you are interested in my research, you can also go to this website.
So thank you for a great talk, which I enjoyed very much. I want to ask about the first research about emotions.
The first one?
The first topic about emotions.
Right.
So it's a great system. I can definitely make use of it when I read text from my wife, for example, and understand what's going on there.
Yeah.
But it seems like, well, how do you extract the emotions? Is it based on the single sentence, just one message, or is it something that has to do with the general context there? This is just one. I wrote many questions. Just answer as many as you want, given the time that you have. The second question is, why are you using a coloring scheme? I mean, you have emojis today,
right.
And it seems like this is the standard today for expressing emotions,
right? Right.
Another question is, have you thought about using emojis for like supervised learning when trying to figure out emotions? So these are just few questions. I have many more.
Okay, okay. Thank you for your question. They are very good questions. For the first question, how do we model the emotions? Actually, in the model, I show you the advanced model. We actually model the emotions within the messages and as well as the context. So we use long short-term memory model, neural networks. And also we model the speaker switch. So we determine the emotion of each message considering the whole dialogue. So that's the first question. And in our experiment, many participants have the same feeling with you, that they have told me that, okay, with this app, I can never see any message with anger emotion. They think that they can make their day better, you know? So I think this is actually you can use in your daily life. And for the second question is about emoji, right? Why we use color, not emoji? Because emoji is actually very small. If you want to use it in the notification bar, and our goal is to make people like realize the emotion immediately. So if you are driving, you cannot read the emoji carefully, right? But you can see the color. So you can decide whether you want to stop or park and deal with this message right now, okay? And also we found some research about the color mapping and the emotions. And we also talk to other HCI researchers about whether we should use different ringtones. But the research about different ringtones are not so many as the color mapping research. So we select the color mapping first. And the third question is, do we consider using emoticon to do some supervised learning? Yes, we do, and it's a very traditional method for emotion analysis. So in the very beginning, we don't have that many data, so we do collect the sentences from the social media, and we use those sentences with only one emoji to treat them as the goal label. Yeah, so thank you. I hope this answers your question.